Now we'll discuss transformations which are called reflections, and this is where our negative signs come into play. So we'll see negative signs out in front of a function, we'll see negative signs in front of our x variable, and those result in different kinds of reflections. So first let's just get a little practice with what's happening. So starting with number 8, it says go ahead and graph y equals absolute value of x, which I've already plotted on the paper here. And then we want to compare that to, first I'll graph absolute value of x, then we want to compare that to y equals negative absolute value of x. So I'll type my negative sign first. Remember, it's negative, not minus, but the negative key down here. So negative, and then math number absolute value of x. So here's my absolute value function, this guy in blue. And then there's y equals negative absolute value of x. So what just happened? We have a reflection, we have a mirror image, and we reflect it across the horizontal x-axis. We reflect it across the horizontal x-axis. Alright, so if we wanted to use the trace key, so right now I'm in my y equals absolute value of x function. If I hit the down arrow, you can see that these numbers turn to red, and I can use the trace key to type, for example, I can see it goes through 0, 0, and then for negative 2, oops, here we go. For negative 2, for x, I have a y value of negative 2, so negative 2, negative 2. For x equals positive 2, I have a y value of negative 2. Going from 0, 0. So I have this kind of upside down V shape. Alright, so we have that reflection across the x-axis. Let's take a look at number 9. Y equals square root of x versus y equals negative square root of x. So here's our square root of x, and then negative second square root of x. So there's our square root of x function in blue, and then below that I can see my red negative square root of x function. And if I use the trace key to identify a few points, let me use the down arrow to get into my red function. So we go through 0, 0, if x equals 1, y equals negative 1. And then since we're dealing with square roots, I'm going to type in the perfect square, x equals 4. And that gives me y equals negative 2. So 1, 2, 3, 4, negative 2. So that's my y equals negative square root of x function. So those two transformations are in green there. So again, we can see that we're reflecting across the horizontal x-axis. Alright, so this is our first type of reflection, and the general way to think of this is if you have a function f of x, if there's a negative sign out in front of the original function, this is going to result in a reflection, reflect across the x-axis. So when you have that negative sign out in front of your function, out in front of the square root of x, out in front of your absolute value, you have a reflection across the x-axis. And the way that I think of this is, you guys remember that f of x equals y, those are interchangeable when we have a function. So when we say we have negative f of x, that's the same thing as a negative y. We're changing the sign of y. So for example, up here we have the ordered pair 2, 2. Down here we have the ordered pair 2, negative 2. So that reflected point. So changing the y-axis, changing the y value bounces us back and forth over the x-axis, reflects us back and forth over the x-axis. So when I see this negative out in front of my function, that makes me think of changing the sign of y. If y's sign is changing from negative to positive or positive to negative, I'm reflecting across that x-axis to make that change happen. Okay, so taking a look at number 10, can you predict without using a graphing calculator what y equals negative x squared will look like when compared to y equals x squared? So again, I have that negative sign out in front of my function. this is the same pattern that I saw for 8 and 9. So I'm going to guess that we would reflect across the x-axis. And now that I've made my prediction without a calculator, let's go ahead and check to make sure that I'm correct. So here's y equals x squared, and then below y equals negative x squared. So there's my original parabola, y equals x squared. And then there's my reflected downward facing parabola, y equals negative x squared. Okay. So looking at number 11, it says, can you predict without using a graphing calculator what y equals negative x squared plus 3 will look like when compared to your original parabola? Well, again, we have that negative sign out in front of our function. So based on what I've seen so far, that should result in a reflection across the x-axis. And then from what we've seen before, when we have a plus 3 just tacked onto the end of our function, that should result in a shift up 3. So reflected across the x-axis, that's what all 4 of these say, and shifted up 3 units. So that's my third choice here. Okay, let's go ahead and check it. There's y equals x squared, y equals negative x squared, and then plus 3. So it looks like it shifted, or sorry, reflected across the x-axis, and then after that it shifted up 3 from what we were seeing back in number 10. Alright, number 12, can you predict without using a graphing calculator what y equals negative, and then parentheses x plus 3 squared will look like? This negative sign, it's out in front of our function. That should be an x-axis reflection, and then the plus 3 inside the parentheses with x should result in a shift to the left 3. So let's see if I'm correct. Down here, negative parentheses x plus 3 squared. So it should reflect and then go to the left 3. Yep, and there we go. Alright, so shifted left 3 units and reflected across the x-axis. And I want you guys to notice the order here. Notice that up here it says reflected across the x-axis and then shifted up. Here it says shifted left and then reflected. So the order is actually significant. You guys, I'm sure, have all heard of PEMDAS, like our order of operations. There's an order of operations for our transformations as well. And we'll talk about this more later. But the order is H, S, R, V. So we handle horizontal shifts first to the left or right. So we shifted left 3 units first. The S is for stretch or shrink. We haven't seen these yet, so we'll see these in a little bit. R is for reflection. That's what we're visiting now, those negative signs. And then V is our vertical shift. So notice up here we did the reflection first, and then we shifted up 3 units. And actually for number 11 it does make a difference. If we shifted up first and then reflected, if we shifted up first and had, this parabola shifted up 3 units, and then we reflected across the x-axis, that will give us this function, but that's not what we got when we graphed that in number 11. So just to revisit that, negative x squared and then plus 3. So remember, instead, we reflected first and then shifted up. So we didn't end up here. We actually ended up here, as you can see in the graph. So I just want to point that out. Okay, so for number 13, I'm going to just put a big X through that. Sorry for making that so messy, but that is not right. That's why I drew it out. So for number 13, y equals square root of x versus y equals square root of negative x. Here's my square root of x function, and let's see what happens when we graph. There's square root of x. Let's see what happens when we graph square root of negative x. Now notice the negative sign is under the square root, and it's in front of the x variable. So there's my original square root function, and there's my square root of negative x function. So let's compare this to what we saw in number 9. Negative square root of x reflected across the x-axis. Square root of negative x reflects across my vertical y-axis. So if I use the trace function, use the down arrow, if I type in an x value of -1, that gives me a y value of -1, because under here negative of -1 is +1, the square root of +1 is 1. If I type in x equals -4, that gives me a y value of +2. So here we reflect across the vertical y-axis. So what's happening here is our x is changing signs, right? So x changes signs where before our y was changing signs. We think of this as f of negative x. Okay? Whatever was happening to x is now happening to negative x. X changes signs, so when x goes from negative to positive or positive to negative, we're going to be reflecting across that vertical y-axis. Alright, number 15, let's graph y equals, so first I'll graph square root of x, then we'll graph y equals the square root of negative x. I'm going to use my right arrow to get out of there and then type my -3. And if you have an older calculator, you would type square root, then the parenthesis shows up, you'll type your negative x, close your parentheses, and then -3. So that's what it would look like in an older calculator, just so you guys know. Alright, so there's our original. That negative x creates a reflection across the y-axis, and then this pulls us down 3 units. So this guy is our reflection across the y-axis. Because x changes signs, then we shift down 3. So reflect across the y-axis 3 units down. And using the trace key, use the down arrow, -1, -2. Oh, I'm sorry, I should type in 0 since it's not at the origin anymore. 0, -3. And then -4, -1. 1, 2, 3, 4, -1. Alright, number 16. Write the equation that would have the shape of y equals absolute value of x, but with the following characteristics. So I'm going to start with y equals absolute value of x, and then I'm going to fill in whatever I need to. Alright, shifted to the left 4 units, shifted to the left 4 units. This will be absolute value of x plus 4. That will create a shift to the left 4 units. And then if I want to reflect across the x-axis, my y has to change signs. My y value would change signs, which means my function would change signs. So y equals negative absolute value of x plus 4. Alright, for part B, shifted to the left 4 units, reflected across the x-axis, and then shifted down 3 units. Okay, we'll start there. So again, shifted to the left 4 units, that's absolute value of x plus 4. Reflected across the x-axis, just like in part A, that's a negative sign out in front. And then shifted down 3 units. I'm going to tack a -3 onto the end of that function. Alright, number 17. Write the equation with the shape of y equals square root of x, but with the following characteristics. Reflected across the y-axis. Alright, so there's my square root of x. If I'm reflecting across the y-axis, that means my x values are changing signs. So this would be y equals square root of negative x. Part B, reflected across the y-axis, and then shifted up 8 units. So reflecting across the y-axis, that's going to be negative x underneath the square root, and then shifting up 8 units, I'm going to tack a plus 8 onto the end of my function.